Okay, this video is for the polyatomic ions quiz, and let's talk about what that means. Poly means many, and atomic means atoms. So some some ions are made of many atoms. So let's talk about what you're used to, what you've seen before. Just as an example, you guys have seen before that calcium sulfide is an ionic compound, and you know that calcium is in group 2, and therefore it likes to become a positive 2 ion, and sulfur is in group 16, and it likes to become a minus 2 ion. So plus 2 and minus 2, they match up, so the formula is just CaS, and you've got your calcium sulfide. So maybe you noticed that on the quiz, when I gave you, or when you took your ionic compounds quiz, maybe you noticed that one of the choices for CaS, if you saw this question, one of the choices was calcium sulfate. And that's something that kids often pick. They often pick it because they've heard that before. They've heard of sulfates before. And quite often kids haven't heard of sulfides before, so that's kind of something new for them. But sulfate is something different. Sulfate isn't just a simple sulfur atom. Sulfate is something more complex. A sulfate looks like this, or at least that's what we think it looks like. So a sulfate ion is 1 sulfur atom and 4 oxygen atoms hooked together. Now, you would think that each oxygen atom has 8 electrons, and each sulfur has 16. So 16 plus 8 plus 8 plus 8 plus 8 is 48. So this thing has 48 electrons. And this thing, as a group of atoms, it really wants 2 more electrons. So it would like to get 2 more electrons. So it would like to have a minus 2 charge. So that kind of makes it a lot like just this sulfide ion. So if you had a calcium atom with its desire to lose 2 electrons, it would kind of like to hook up with this giant sulfate ion. So the formula for this would be just CaSO4. So this would be calcium sulfate. That's how easy polyatomic ions is. So it's not so much about memorizing, oh yeah, sulfate is SO4, because quite often, I mean always, you're going to have this table, or a table like this, available to you. So if you look at this, what do you see? Where's our sulfate? Sulfate is SO4, and it's minus 2. So in your mind, what you should probably do is you should probably think of each of these polyatomic ions. You should probably think of them as just single atom ions, but made of more than one atom. Okay, maybe I shouldn't have said it that way, but take a look right here. Sulfate is minus 2. So that means this group of atoms right here, these 5 atoms, this SO4, these guys behave like a single minus 2 ion. That's why they hook up with a plus 2 calcium ion to make calcium sulfate, or magnesium sulfate, or what else is in group 2? Calcium, magnesium, what, barium? Barium sulfate. So now, 4 minutes into this video, all of a sudden you realize how easy this quiz is. You're like, oh my goodness, okay, so that means bromate. Bromate is a group of 4 atoms, 3 oxygens and 1 bromine, and it behaves as if it were a minus 1 ion. Oh, okay, so what if I had a plus 1 ion like sodium, because you guys know that sodium likes to lose 1 electron and become plus 1. So if it were to hook up with a bromate, you'd have this. You'd have NaBrO3. This thing is just sodium bromate. It's that easy. So what if we went back to our calcium plus 2 ion and hooked that up with bromate? Well, let's see here. Calcium is plus 2 and bromate is -1. So if we kind of pretended that bromate was just a single atom, then we would need 2 of them, because calcium is +2. So calcium bromate is going to be CaBrO3, but we need 2 of these, so we use parentheses and we put a little 2 here. So the point of this is that the calcium is +2, just like you guys already know, but the bromate, each bromate is -1, so we need 2 of them to make the compound work. +2 equals -1, -1. So the formula for calcium bromate would be CaBrO3 2. I'm 5 minutes 42 seconds in, so maybe I should just do one more of these. So let's do magnesium phosphate. So phosphate is right here on our polyatomic ions chart. So phosphate is PO4 3 minus. So it's PO4, and it has a -3 charge, or it wants to have a -3 charge. We know that magnesium is in group 2, so it wants to have a +2 charge. So if we want to make magnesium phosphate, how do we do this? Well, we go, okay, we got +2 and -3. What's the smallest number that 2 and 3 both go into? That is 6. So if we have magnesium and we need a +6, we need 3 of them, because +2 +2 +2 equals +6. So I need 3 magnesiums. My phosphate, however, my phosphate is a -3 charge. So how many of those do I need to make a -6? I need 2 of them. -3, -3. So I need PO4, but since I need 2 of these, I'm going to use parentheses, and I'm going to put my little 2 right there. So this is the formula for magnesium phosphate. Okay, I think I might have gone a little fast on this video, but I think if you can see the polyatomic ions quiz, you're already comfortable with naming ionic compounds. You've already passed the covalent compounds quizzes. So I think you're probably good to go.